G'day folks, I've had a couple of questions about successive parts of exercise 2I. So in this video I'm going to run through and do 3 examples from questions 8, 9 and 10. So I'm going to do part A from each of questions 8, 9 and 10. I'm going to do part E from each of 8, 9 and 10. And then I'm going to do the last part. So in question 8 it's part L, in question 9 it's part H, and question 10 is part P. So I'm going to go through 9 examples. Okay. At the end of every 3 examples, there's going to be a break. There's going to be some questions for you to answer. The pop-up are questions from me to you. They're not an ad, don't skip them, okay? Got to answer the questions. So I've got question 8, A, E and L up on the board here behind me. You've always got to remember, always go back to your index laws, go back to your definitions, right? So what's the index law that we use when we're talking about fractional indices? You know, a to the power of m over n is the nth root of a to the m. I know that it looks ugly, but just crank away, right? Just follow the rule. Don't worry about how ugly or how easy or how hard the question looks. Just crank away, right? Unless there's something that says, well, hang on a second, what do I do now? And then we think about some of the other index laws. Let's watch and see what happens, right? So for part A, I've got 8 to the power of 2 on 3. Well, if I follow the index law, that's going to equal the cubed root. Now, cubed because there's a 3 in the denominator. So the cubed root of 8 squared. Well, what's the cubed root of 8? What number multiplied by itself 3 times gives me 8? It's not hard, guys, because the cubed root is going to be less than that number. So you've just got to come up with a number less than 8, where if you multiply it by itself 3 times, you get 8. Well, 1 times 1 times 1 is not 8. 2 times 2 times 2, 8, right? So the cube root of 8 is 2. So this thing is 2 to the power of 2. The cube root of 8 is 2. I've still got my power of 2 there. So cube root of 8 is 2. 2 to the power of 2, that's pretty straightforward. That's 4. Okay. I hope that's like, okay. Let's have a look at part E. Okay, this time part E I've got a negative index. Yuck. Okay, don't panic about the negative index. Remember what a negative index means. A negative index, I did a video on this before. You've done a whole exercise on negative indices. A negative index means that the number is on the wrong side of the vinculum, the wrong side of that fraction line. Okay, so 16 to the power of negative 3 on 4 just means 1 over 16 to the power of 3 on 4. Okay, well now I just turn the handle, right? What does 16 to the power of 3 on 4 mean? Well, it means, I've still got the 1 over, it's the 4th root of 16 cubed. The 4th root of 16, a number multiplied by itself 4 times that gives me 16. Okay, it's got to be less than 16, so just start 1 times 1 times 1 times 1, that equals 1, that's not 16. What about 2? 2 times 2 times 2 times 2, well 2 times 2 is 4, times 2 is 8, times 2 is 16, so the 4th root of 16 is 2, so I've got 1 over 2 to the power of 3, well 2 to the power of 3 is 2 times 2 times 2, that's 8, so the answer is 1 over 8. Okay, let's keep on going. Part L gives me 10 over 100 to the power of 3 on 2. Don't panic, you see a fractional index, just follow the index law. Don't let it freak you out, just follow the index law. So there's no negative powers, there's nothing weird about it, it's just 100 to the power of 3 on 2. I'm not going to panic, I'm just going to follow the index law. Right? So what does that tell me to do? Well, I need the square root of 100 to the power of 3. Okay, what's the square root of 100? What number multiplied by itself gives me 100? Obviously 10, that's an easy one. So I've got 10 over 10 to the power of 3. Okay, well, hang on, what's going on here? Look at this, I'm dividing 2 things with the same base. What does the index law tell me to do? When I'm dividing things with the same base, I subtract the powers. Okay, so in other words, that's going to give me 10 to the power of 1 divided by 10 to the power of 3. If I subtract the powers, I get 10 to the power of -2. Okay, now I've got a negative power. Don't panic. What does the index law say? It means it's on the wrong side of the vinculum. 1 over 10 squared. 10 squared is 10 times 10. So it's 1 over 100. Okay, now you might need to sort of, pause and rewind and go over that one a little bit slower. But all I did was I looked for a place where I could apply any index law that came up, right? So negative power means numbers on the wrong side of the vinculum. Fractional power means I apply the index law for fractional indices, right? Whatever comes up, don't panic. Don't let it freak you out. Just one step at a time. I didn't look at this and say, oh, it's 1 over 100. That's easy. I had no idea until I started to work my way through. I had no idea what the answer was going to be. But I just relaxed. I didn't freak myself out. I just said, okay, what index law? How do I use it? What index law? How do I use it? What index law? How do I use it? And I kept on going. Right, guys, that's the end of the examples for question 8. The video is going to pause for a moment. When it does, make sure you answer the questions that pop up in the stream. When we come back, after you've answered those questions, there's going to be exercises for question 9 on the board. Alright guys, welcome back. I hope those questions were okay for you. Let's have a look at some parts from question 9 now. So I'm looking at 9A, 9E and 9H. They're on the board behind me. Look, don't panic. Think about the index laws and apply them. That's all you've got to do. Right? Don't sit there and think, oh, what do you do here? What do you do? Just go back. There's only a half a dozen or so index laws that we need to know. Right? When we're multiplying with the same base, we add the power. When we're dividing with the same base, we subtract the power. When we've got a fractional index, it's going to be the root of the number to a power. When we've got a negative index, it's on the wrong side of the vinculum. All these little rules basically sort of come together and we just apply them as needed. So let's not panic. Let's look at this thing and see what we do. Look at this, same base. Okay, I'm multiplying two terms with the same base. Well, in that case, I need to add the indices. So I've got a to the power of a half times a to the power of 3 on 2. It's a to the power of 1 half plus 3 on 2. Well, a half plus 3 on 2 is 2. Well, it's just a squared. It's that easy. Okay. If you wondered how I did that, it's not some sort of secret 1980s maths trick. I've got 1 half plus 3 halves is 4 halves. Well, 4 halves is 2 wholes, right? 4 over 2 is 2 wholes. All right, what about down here? Remember the index law that says if I've got a power on a power through brackets, then I'm just multiplying those powers. Okay. We had a whole exercise on this index law earlier on in the chapter. Okay. Maybe 2E, I think, I'm not sure, 2B or 2D or 2E, around there. But you've seen this index law before, right? So the index law at play is a to the power of n to the power of m is a to the power of n times m. It's just that index law, that's all. So I'm just going to do that here. S to the power of 3 on 2 to the power of 4 on 7. I'm just going to multiply the powers. So I've got S 3 over 2 times 4 over 7. 3 times 4 is 12. 2 times 7 is 14. And then whenever I see a fraction with common factors I want to simplify, 12 over 14, I need to find a number that goes into both. 2 goes into both 12 and 14, so I divide both by 2. So I get S to the power of 6 on 7, dividing both top and bottom by 2. And that's it, that's the answer. Okay. Now the last one, H, is up here. Okay, 2 index laws at play. One of them was that if I've got A over B to the power of n, so if I've got a fraction in a bracket to a power, that power goes to both the numerator and the denominator. So here I've got a fraction to a power, that power goes to both the numerator and the denominator. And the other law says that if I've got a power on a power that they multiplied, just like we saw in this example here, right? So just like these powers multiplied, and the powers here are going to multiply. So, 2 over 3 gets multiplied by 3 over 4. So I've got a to the power of 2 times 3 is 6, 3 times 4 is 12. Then on the bottom, b, 4 times 3 is 12, 3 times 4 is 12. Okay, a to the power of 6 on 12, well 6 over 12 is a half. A to the power of a half. 12 over 12 is 1, so it's just b to the power of 1. Okay, again, just like last time, guys, you might have to pause that one and go through a little bit, go through that a little bit slower. But all I did was just apply index laws that we've already seen. There's nothing new in any of this. It's just getting an idea from here and an idea from there and putting it together. Guys, look, you're in 5.3, you're in Year 10 5.3. As you move on, there's very, very little that you're going to come across that's going to be new. All that you're going to see is going to be applications of things that you've already seen. And what makes it quote unquote hard is that you need to have this idea, and you need to have that idea, and you need to have that idea, and you need to be able to bring all of them together. And it can get complicated, right? So that's just the nature of the beast. Don't sit there and say, whoa, how am I supposed to remember this thing from like X months ago or X weeks ago? You're a Year 10 5.3 student. You're meant to remember. Guys, coming right up, there's questions. Don't skip past them. Answer them, and we'll be right back with examples from question 10. Alright guys, welcome back. I hope those examples from question 9 were helpful in the questions that you just had a crack at. We're now going to look at 3 from question 10. The last one's a little bit juicy, right? There's a fair bit in the last one, but it is the last one there. It's meant to be the hardest one, right? So let's have a look, starting at 10a. I need to simplify the square root of 25s to the power of 4. Well, what does square root mean? Square root means I've got to the power of, or first of all, I've got the square root of that multiplied by that. So when I've got a radical of things being multiplied, it's the radical of each one of them. So this is the square root of 25 times the square root of s to the power of 4. Okay, so what's the square root? The square root of 25 is just 5. What number multiplied by itself gives me 25? That's 5. And then the square root of s to the power of 4. Well, what does square root mean? Square root means to the power of a half. So that's s to the power of 4 over 2. Right? That's that index law in reverse thing that we saw in question 8. No, in question 7. Yep, question 7. I'm pretty sure it was question 7. So we've covered it in an earlier video anyway. So the square root of s to the power of 4 is s to the power of 4 on 2. Well, that's 5. 4 divided by 2 is 2, so it's just 5s squared. Okay, hope that helps. What about over here? Well, I've got a power of a power inside a bracket. They just multiply together. We saw that in question, come up a couple of times in question 9. So that's going to be x to the power of 3 times 1/3. Well, if I've got 3/3, I've got 1 whole. So it's just x to the power of 1. That's it, there's nothing more to it. Right? If you want to multiply it out, you can say, well, 3 times 1 is 3 over 3. Well, 3 divided by 3 is just 1, so it's just x to the power of 1. Okay. Now, let's get on to the juicy one. Let's get on to part P. A lot in it. There's a fair bit in P, I'll be honest. So what I might do is, just to give myself some more room, is I might clean this part of the board up. So if you want to get that down, now's a good time to pause the video and write that down, because it's going to be going in just a moment. Okay, so pause, good, come back, righto, let's go. Okay, so part P, we've got 10 squared x to the 4 over 0.01 to the power of 1/4. Now, as I said, right, there's a fair bit in this one. In fact, there's a lot in it. Right? Let's do one at a time. What's this 0.01 thing? Now remember, you're meant to be doing these, if possible, without a calculator. Okay? If possible, without a calculator. So we don't want to go, well, 10 squared divided by 0.01. Let's think about what we know about the index laws. What is 0.01? 0.01, well, that's 1 over 100. That's 1/100th, literally. Well, what's 100? 100 is 10 to the power of 2. So I've got 1 over 10 to the power of 2. Well, from the negative index laws, we know that that's 10 to the power of negative 2. So this 0.01 is 10 to the power of negative 2. So let me rewrite that. We've got 10 squared x to the 4 over, not 0.01, but 10 to the power of negative 2. Okay, so what do we do now? Well, look at this. We've got two things with the same base that are being divided. What does the index law tell us? Well, the second index law we saw says that when we're dividing them in the same base, we subtract the powers. So 10 to the power of 2 divided by 10 to the negative 2, if I subtract the powers, I get 2 minus negative 2. Well, 2 take away minus 2 is 2 plus 2, so it's 4. So that's going to be 10 to the power of 4. So 10 to the power of 2 divided by 10 to the negative is 10 to the power of 4, multiplied by x to the 4 to the power of a quarter. Well, look at this. I've got a product of things being raised to a power. Well, that means that power goes over both terms. So that means I've got 10 to the 4 to the power of a quarter times x to the 4 to the power of a quarter. Well, I just multiply the powers. Right? So 10 to the power of 4 to the power of a quarter. Well, 4 quarters is 1 whole, just like we saw in the last example, the one I rubbed off. 4 times a quarter is 1, so that's just 10 to the power of 1. X to the power of 4 to the power of a quarter, well, that's just 4 times a quarter is just 1 again, so it's just x to the power of 1. So it's just 10x. Okay? I'll be honest, guys, there was a lot in part P there. Okay? So look, don't sit there and beat yourself up, especially now because you haven't even had to go at any of the other sort of parts of question 10 on your own. In fact, you haven't even gone back to do questions 8 and questions 9 and all the earlier parts of question 10 yet. Doing them will help you build up your skills. Anyway, little exit, couple of questions down below, just for question 10. Please answer them, and then get back to the exercise and have a go at whatever you can from questions 8, 9 and 10. I want about a half an hour's worth of work, a solid half an hour's worth of work out of you today for questions 8, 9 and 10. Don't sit there and just dedicate yourself to all of question 8. If you're doing question 8 and you're pretty confident with what's going on, jump ahead, go to question 9. If you're confident there, jump ahead, go to question 10. But give me a half an hour's worth of work. Thanks very much, guys. Work hard and feel free to ask me any questions you need.